I'm Seema and welcome to part 28 of the chapter Hydrocarbons. We have two more students today. They are very much interested in the class. They just don't want to stay out of the room. So they are going to be here, only they won't sit on one seat. They'll run around and they are going to help us understand the topic. So, girls, you can be here. Come on. Be quiet, okay? In today's video, we are going to move on with our discussion of the chemical properties of alkenes. And in this video, we are going to talk about the oxidation of alkenes. The oxidation of alkenes can be carried out by an oxidizing agent. And it can be done under two conditions. One, when you have a mild oxidizing agent, and the second is when you have a strong oxidizing agent. Under the two conditions, the products that we get are different. So let us dive into it and see what happens when we use a mild oxidizing agent. We can carry out the oxidation of alkenes with aqueous potassium permanganate solution, which is cold and it is dilute. Aqueous means you've added water to it, and therefore it is a dilute aqueous potassium permanganate solution, and we keep the temperature low, which means the conditions are milder. This mixture is known as Bayer's reagent. It has been given a name, that is Bayer's reagent. When you carry out the oxidation of alkenes with the help of Bayer's reagent, what happens? The alkenes, they give vicinal glycols. And when you carry out the oxidation of alkenes with a strong oxidizing agent, that is, we convert the same oxidizing agent into a stronger one by changing the conditions, making the conditions more drastic, that is, by raising the temperature, by making it concentrated and in an acidic medium. Under those conditions, the products that we obtain would be different. So when we have the milder conditions and the oxidizing agent potassium permanganate is known as Bayer's reagent, what happens? You have this alkene. Alkene, that is ethene. The double bond is between these two carbons. What happens is that when you put Bayer's reagent in it, the pi bond, that is the second bond, the electrons of the second bond are loosely bound. You know that. The first bond is a sigma bond, the second bond is a pi bond. So the electrons of the second bond are not so strongly bound. So this weak oxidizing agent can come and break the second bond. When it breaks the second bond, the oxidation occurs and two OH groups will come and attach themselves. As soon as the second bond breaks, both the carbons get back their electron and H2O and O will result in two OH groups. There are two oxygens, two hydrogens. So you will have two alcoholic groups, OH groups. Both the OH groups will come and attach themselves to both the carbons, which were attached by a double bond. So basically what is happening is just the second bond is breaking and the OH groups are going to come and attach themselves to both those adjacent carbons. When you say there is something they are neighboring carbons. When something is in the neighborhood, what do you call it? It is in the vicinity, right? It is in my neighborhood. It's in my vicinity. So when you have these alcoholic groups attaching to two vicinal carbon atoms, vicinal means neighboring carbon atoms. Such compounds are known as vicinal glycols. A glycol is an alcohol which has two alcoholic groups. And vicinal because the two alcoholic groups are attached to two neighboring or adjacent carbons, which is understandable. Why would it be adjacent? Because the pi bond broke between these two carbons. So naturally, the addition will also take place at these two carbons. So it results in the formation of vicinal glycol. Looking at it again, you had CH2, double bond CH2, the second bond broke in the presence of dilute potassium permanganate at a temperature which was pretty low, that was 273 Kelvin, which is 0 degrees Celsius, and the two OH groups attached to the two carbons. If you take the second example here, CH3, CH, double bond, CH2. What is this now? This is propene. If propene is made to react with water and oxygen, that is dilute potassium permanganate at 273 Kelvin, which the dilution is causing the water and the oxygen is being provided by the potassium permanganate, the oxidizing agent Again, you will get vicinal glycol. The second bond here will break. So obviously the two OH groups will attach themselves to the two carbons which were attached by a double bond. So the two OH groups will attach themselves to these two carbons and the second bond will vanish. So you get the CH3CH remain as such, and to this CH you get an OH group here, and to the CH2 here you get the second OH group here, which is propane 1,2-diol, which is a vicinal glycol again. So you get propane 1,2-diol, or vicinal diols are what you are getting here with Bayer's reagent. There is one very important point about the Bayer's reagent, which is very useful in the laboratory. You know, when we carry out reactions in the laboratory, we can't see what is actually happening. We don't know which atom is going where because we can't see atoms. But what our eyes can see is a change in color or a certain smell. So our observations are always related to our five senses. What are we going to, does it taste? Like if you taste acids, they would be sour. If you taste a base, it will be bitter. So your five senses tell you is how you will be seeing them in the laboratory. Although you are never supposed to taste acid, any chemical in the laboratory. Yet, if you take natural acids and anything in your, the foods that you eat, anything that's bitter like sauerkraut, Karela, it is basic in nature. And anything that is sour like lemons, that is acidic in nature. So you can tell from the taste, from the smell, from the vapors rising, from the change in color, you can tell the difference. So what happens here is that when you use Bayer's reagent is potassium permanganate solution, which is purple in color. And it is dilute, which means the potassium permanganate is not in a very huge quantity. So when you carry out this reaction, the potassium permanganate can get used up. So the purple color of potassium permanganate starts vanishing. And when it vanishes, that gives you an idea, okay, it means the potassium permanganate was used up. It would not have been used up unless it has carried out the oxidation. And it can carry out the oxidation of only unsaturated compounds. That is, compounds which have double or triple bonds. So naturally, if potassium permanganate decolorizes, what does it show? It shows that a double bond or a triple bond is present in the organic molecule. So if you've been given a sample and you carry out an organic sample and you carry out its reaction with potassium permanganate, that is Bayer's reagent, and the color of Bayer's reagent, it decolorizes, it gets lighter or it simply disappears, then it means that the compound is unsaturated. So we say that since the color of Bayer's reagent decolorizes, this particular reaction can be used as a test for unsaturation. Having said that, let us carry on with our discussion of oxidation. This was a mild condition. Oxidation carried out under mild conditions. If you carry out the oxidation under more drastic conditions, that is, if you take the same oxidizing agent, but now what are we doing? We are turning the potassium permanganate, we are increasing the temperature, it is hot. It is acidic, we add an acid to it. And since it is acidic, it will make it more harsh. So we add acid, we increase the temperature, the conditions are becoming more and more drastic, and we have potassium permanganate now as our oxidizing agent. Under these conditions, the oxidizing agent turns into a strong oxidizing agent instead of a weak oxidizing agent. What's the difference? The weak oxidizing agent, what did it do? It came and it attacked the weaker bond and it broke the weaker bond, that is the pi bond. It could do nothing to the sigma bond because the sigma bond is stronger. But when the oxidizing agent becomes stronger, it does not attack just the pi bond, it comes and attacks the complete double bond. It comes and attacks this unsaturation totally. And it breaks the alkene into two parts. Now when it breaks the alkene into two parts at the double bond, wherever the double bond was, it will come and break it totally. And when the two parts are broken, both the carbons are now dangling. The same thing had happened here also. When one bond broke, both the carbons had one electron and their octet was not completed. And they had to complete their octet, and that is the reason why both the carbons decided to attach OH to them to complete the octet. Here also, both the bonds are broken, and therefore now both the carbons are in need to attach with something, to add on something, to get oxidized in order to give you the products. But here we got one product because the molecule had not broken. While here, since the molecule itself breaks, you get more than one product. One half will give you one product, the other one or two products, and the other half will give you other products. And depending on the nature of the alkene and the reaction conditions. What is the nature of the alkene? You have to see what these two carbons are like. If the two carbons are attached to two hydrogens, are they attached to alkyl groups? Are they attached to an alkyl group and a hydrogen? Depending on the nature of each of these carbons, the products will be determined by that. You will understand this when I explain this further. Let us first see this reaction. And let me first read this out. Acidic hot potassium permanganate acts as a strong oxidizing agent. In place of potassium permanganate, you can use another oxidizing agent as potassium dichromate too. These strong oxidizing agents, the strong oxidizing agent that you used, it will oxidize alkenes and it will result in the formation of ketones or carboxylic acids or carbon dioxide and water. And the products will depend on the nature of the alkene and the experimental conditions. Why experimental conditions? If the conditions were mild, you would have got a glycol. But since the conditions are strong, you are going to get different products. So oxidation is occurring, but what will decide what the product is? Whether the oxidizing agent is mild or strong, that is the condition of the reaction, whether it is cold or is it hot, is it diluted or is it acidified. So depending on that would the products depend. If it is cold dilute, you will get glycols, vicinal glycols, you know that, or vicinal diols. But in the case of a strong oxidizing agent, you will get different products. So here you have 2-methylpropene, one example we are taking. 2-methylpropene. It's propene and the second carbon, the double bond is between the first and the second carbon, and the second carbon has a branch, that is CH3 here. So this C is attached to two CH3s and this carbon is attached to two hydrogens. Our focus is always on the two carbons which are attached by the double bond. When you have potassium permanganate under acidified conditions and you are heating it up, now the conditions are drastic. It is acting as a strong oxidizing agent. At this time, the potassium permanganate is going to break this molecule completely at the double bond. When it breaks, the carbon, this carbon, and is going to, the alkyl groups or the hydrogens, whatever is attached to the carbon, that part is not going to be affected. Only the empty space that is created by the breaking of the double bond, those electrons or those valencies that need to be satisfied, they will result in the addition of something. And addition of oxygen and hydrogen as oxidation is occurring. So here what do you see? When I say addition of hydrogen, one can get confused that addition of hydrogen is reduction. But when you have hydrogen and oxygen adding on, the overall together, like you have here OH and OH, you will say hydrogen is positive and oxygen is negative. Although hydrogen may be positive and oxygen is negative, oxygen is 2 negative and hydrogen is 1 positive. So on the whole, the negative charge is increasing. So it will still be oxidation. You know, this can sometimes be a little confusing for students. But don't get confused. Even if OH are adding up to it, it is still getting oxidized because the oxygen, that is the negative charge that is increasing, is more. So when you have 2-methylpropene, this carbon with 2 methyl groups results in the 2 methyl groups are here, this carbon, it attaches to oxygen, results in the formation of a ketone. So what ketone is this? CH3, COCH3 will be propan 2O. And this carbon, which is attached to 2 hydrogens, will result in the formation of carbon dioxide and water. Right? The second carbon results in the formation of carbon dioxide and water. Now moving on to another example. I'll explain why these products are formed. Right now I know you will just feel that what is this? How did it out of the blue? What is being formed? You'll understand this very quickly. Let us just see one more example. This is butadiene. Till now, you just have to remember when this happens. when the strong oxidation occurs, you will either get a ketone, or you will get a carboxylic acid, or you will get carbon dioxide and water. In this case, we have butene, which is a symmetrical alkene. On both the sides of the two carbons which are attached by double bond, each carbon is attached to one hydrogen and one methyl group. Do you see here? CH3, CH, and this is also CH3, CH. When you carry out its oxidation, strong oxidation with potassium permanganate acidified at a higher temperature, what do you get? You get the bond breaks here, and CH3CH remains as such, but the CH3C becomes COOH. CH3C becomes COOH. Here CH3 remains as such, and this becomes COOH. Two oxygens are adding and resulting in the formation of ethanoic acid. Since both the carbons were identical, how were they identical? That both of them had one methyl group and one hydrogen attached to them. This also had one methyl group and one hydrogen attached to it. Therefore, both of them gave the same product. What was the product? CH3COOH. Do we understand something from these reactions? When is carbon dioxide and water being formed? When is a ketone being formed? And why was a carboxylic acid formed here? And remember the language that was there, that it depends on the nature of the alkene. Nature of the alkene, actually, it is just the nature of the two carbons. What is the difference between the nature of the two carbons here in both of these examples? Let us look at every carbon. This carbon is attached to two alkyl groups. Do you see? Methyl, methyl. This carbon is attached to two hydrogens. These two carbons are attached to an alkyl group and a hydrogen. This is the difference. When a carbon is attached to two alkyl groups, it will result in the formation of a ketone. When a carbon is attached to two hydrogens, it will result in the formation of carbon dioxide and water. And when it is attached to one alkyl group and one hydrogen, it will result in the formation of a carboxylic acid. That is the basic difference. So if you get a reaction and you don't know what the products are, now you will be able to just find out for yourself. You would know which would be the product. If both are alkyl groups attached to the carbon, you will first locate the two carbons with the double bond. Then you will look at both the carbons which are attached to the double bond. If the carbon, now this is where the carbon-carbon double bond breaks, and we know that every carbon is forming two more bonds because carbon is tetravalent, it forms 4 bonds. If it is forming 2 bonds with the next carbon, it means it has 2 other bonds. So now you have to look at these 2 other bonds for both the carbons, and with the help of that you will get the products. And the products will be multiple because the bond is breaking completely. So if you have carbon which is attached to 2 other hydrogens only, no alkyl group, under these conditions, that is, when you have strong oxidation, potassium permanganate under acidified conditions at a higher temperature, you will get carbon dioxide and water. If one of the carbons is attached, any of the carbons is attached to an alkyl group and hydrogen, then the product will be a carboxylic acid. Now, when you write down the products, you have to take both of them. First, you will look at this carbon and write the products according to it. Then look at this carbon and look what is it attached to, and write the products according to that. Those will be the products of your reaction. So if an alkyl group and hydrogen is attached, then you will get, in the presence of KMnO4, which is acidified potassium permanganate at a higher temperature, will give you carboxylic acid. If the carbon is attached to 2 other alkyl groups, then with acidified potassium permanganate at a higher temperature, that is when strong oxidation is carried out, the product that you get is a ketone. Right? Once more, related to the examples we took. Here, the carbon was attached to 2 alkyl groups. 2 alkyl groups will result in a ketone. This carbon was attached to 2 hydrogens. So, 2 hydrogens will result in the formation of carbon dioxide and water. And that was what was formed. And these 2 carbons are 1 alkyl group and 1 hydrogen, CH3 and H. So, both of them resulted in the formation of carboxylic acid. So before I wind up this topic, let us take one more example and carry out the oxidation of this alkene by both the processes, that is by using a mild oxidizing agent, potassium permanganate, and by using the strong drastic conditions, that is a strong oxidizing agent, potassium permanganate. So here you have a benzene ring. This is CH2, and we dilute potassium permanganate at 273 Kelvin. The conditions, what does this show to you? That we are now using Bayer's reagent. Bayer's reagent is a mild oxidizing agent. Since it's a mild oxidizing agent, it is not going to break the molecule. It is only going to be able to break the second bond, that is the pi bond. And when the pi bond breaks, both the carbons will attach the OH groups to it. That is the alcoholic groups, and you will get a glycol. And that is what we got. In the second case, what did we do? We took the same molecule, we carried out the oxidation under stronger conditions, under more drastic conditions. It was at acidified potassium permanganate at a higher temperature. Now the double bond, look here, these double bonds are not breaking. The alkene, the bond that will be breaking will be this one. Why? Because these, you might feel, why the double bond is here also, and so why aren't these, this is also in a way it is benzene, but it is an ene. But in benzene ring, the double bonds that are present, they are resonating. There is resonance in the benzene ring, which gives it more stability. So for the acidified potassium permanganate at a higher temperature also, it is not possible for it to break the double bond of a benzene ring. But it can break this bond, which is dangling, which is loose. It is not being stabilized by anything. Therefore, the bond that will break will be this one and not a double bond of the benzene ring. One thing in both the cases, whether it is dilute or concentrated. Even with concentrated conditions, you will not have the double bond of the benzene ring disintegrating or breaking. You will have the double bond of the ene that is here, the alkene between the two carbons here, which will break. So that is what happens. So our focus now we are supposed to find out what are the products. So our focus are these two carbons. To this carbon, what all is attached? A benzene ring, which is an alkyl group, an aryl group, but it is R, okay, and hydrogen. So R and H. So this part, what will it give us? The R remains as such, so you write the R as it is, that is the benzene ring, and the carbon will get converted into COOH. So the carbon here will get converted into COOH. You got your product, benzenoic acid. And the second carbon, which was attached to the double bond, look at this here now. This is attached to two other hydrogens. If it is attached to two other hydrogens, what do you get? You get carbon dioxide and water. So what are the products that you get as a result of this carbon? You'll get carbon dioxide and water. If this carbon was attached to two methyl groups, let us assume. If it was attached to two methyl groups, what would you have got? If it was attached to two methyl groups, let me just change this here now. So CH2 for the strong oxidizing. If it was CH2, CH3, CH3, then what would your product have been? If this was CH3, CH3, then you would change this. Instead of the CH2 here, you would get CH3, CH3. Okay? This would have been on mild, that is with Bayer's reagent. And on strong oxidation, you would not get carbon dioxide and water now. You would get the same carbon, the CH3 with carbon and double bond O. You would have gotten a ketone. Right? So if you just have to look at the two carbons which are attached by the double bond, and looking at the nature of those two carbons, you will be able to determine the product of oxidation with Bayer's reagent and when potassium permanganate is used as a strong oxidizing agent by acidifying it and by heating it up. That is at a higher, carrying out the reaction at a higher temperature. So this was the oxidation of alkenes. And with this, I'll wind up the video. If you wish to watch the other videos of this chapter, please click the link that will appear on the top of your video, and that will lead you to the playlist of the chapter, and you can find all the other parts of this video in that playlist. Also, if you visit my channel, you can look for the playlists for different chapters for classes 11 and 12, and I have already made playlists for different chapters. So just go to the playlist, check the whole chapter. You will have a list of all the videos included in that chapter, and you can just do all those chapters that I have already covered. So I do have a library of a number of chapters that I have already covered. So I would encourage you to visit those, and I hope it helps you in preparing for your exams and for just understanding chemistry as such. So with this, I'll wind up the video. If you found it helpful, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.